So what's next? It will be a bunch of combinatorics again. Okay, so we are now going to write something called PMF or PDF. PDF stands for probability distribution function or probability density function, and also probability mass function, which are a bunch of names of the same thing. And you are going to see this kind of thing. It's just a bunch of names. You have already known most of them. Ballooning means you toss a coin one time, one success, the chance, we write a number to represent it, we call it theta. Okay? So that means what? That means if a coin is fair, either head or tail, we don't care about the probability that is in the middle, then the sample space is head or tail, and the probability is, let's say fair, that means 0.5. That means for ballooning random variable, theta is 0.5. It means the probability of success. Then if we have many coins tossed together, let's say n times, and I want k success, then this is exactly n choose k in combinatorics. And then you just put the binomial expansion here and multiply the corresponding probability, then you get the answer. Then what about trinomial? Okay, the same thing. Suppose you toss a coin, due to some magic reason, you can land it on the vertical line. Now you have 3 outcomes. And then you also have something called uniform. All the video game RPG weapons are using uniform. We'll talk about this soon. And then you also have geometric. What's geometric? Is that you toss the coin k time, every time fail except the last one. So that means what? If you toss a coin 5 times, and you fail the first 4 times, then what's the probability? The fail probability multiply itself 4 times. And the last time is success. Then you multiply the success probability in the end. So 4 fail and 1 success, that means fail power 4 times success power 1. Then that's the so geometric. And this thing is a special case of this crazy thing, which, don't worry, I put this here because you have seen what is hypergeometric function. This is exactly the same thing. Okay. Then we also have negative binomial. Okay, this is the name from the probability. Actually, this is binomial with repetition. So I'm saying I toss a coin n times, k fails. And lastly, I have something called Poisson. This is the only new one. Okay, this is the only new one. That means what? That means everything here, except this crazy one, you have already seen it in combinatorics. The last one is new. Okay, let's talk about the formula. Again, this one you don't need to worry about it. This one is just crazy, okay? So what's this? If theta is 0.5, very simple. Theta 0.5 means what? Means half of the chance you success. What's my x? My x is 1 or 0. Let's say 0 means fail, 1 means success. So if x is fail, then x is 0, right? What is this? 1 minus x, 1 minus 0 is 1. So then we have 1 minus 0.5. This gives me half, right? I fail, right? Fail means x is 0, so this guy is power 0. I don't care this, so I have this 0.5. What does it mean? My failing chance is half. What happens if I success? If I success, x is 1, right? Then 1 minus x is 0. I don't care about this bracket. I care about this bracket. So I have theta. Theta power 1. Theta is actually the success chance. So I get the chance of success. So that means if my coin is not fair, let's say the coin success rate is 0.7. That means what? I toss 1 time, success is 0.7, fail is 0.3, it's actually this thing. It looks very complicated. No, it's just 0.7 and 0.3. That's it. Because in this particular case, okay, this actually is wrong. It should be 0 and 1. That means you only have 0 or 1. Ballooning means two cases. Okay? Then if I repeat this thing, what? Many times, then I have binomial. So, in other words, let me recap. You see this binomial, right? This thing, n. Now you can think of this as the same thing as in the probability. This is what? 1x power 0, that means fail. Plus 1x power 1, that means success. Okay, and then you have this n. Then you naturally see this guy. But we have probability, so we need to care about the theta. The theta is just probability. So now you have binomial. It's the same thing. Nothing changed. And then you also have trinomial. So again, you have 3 things. Then you do the same thing. And now because trinomial or multinomial, we don't write n choose k, we write n choose k1, k2, k3. What is this? N factorial divided by k1 factorial, k2 factorial, k3 factorial. And multiply the corresponding success chance. This kind of thing is very common in the football. Okay? What about uniform? Uniform, very simple. You have n people. The chance of selecting one particular person, all of them are equal. So you just do 1 over n. So that means evenly distributed. And then you have geometric. Geometric is what? You toss k time, all the first k minus 1 time fail except the last one. So all the first k minus 1 time, so suppose you toss 10 times, all the first 9 times fail. So you have fail times 9, multiply itself 9 times, and this is success. Theta means success, okay? Theta means success. Then what is 1 minus theta? Means fail. So fail 9 times, success last time. Trivial, right? Ignore this this crazy one. What about this? This is, remember this bracket? This is n choose k with repetition. Okay, remind you. So what is this thing? This is n plus k minus 1k. Okay. So what is this? This is different from binomial. This is n success, n time k success. This is n time but k fail. Slightly different. And why they call it negative? You can think of success is positive, so fail is negative. That's why people call it negative. Okay. Lastly, this is new. This one is new. I'll talk about it. And this one is actually very useful. Okay, I don't know where you live. Probably some of you live very far away, and every day you need to stuck in the bus station and wait for so many buses. And let me tell you, you can actually plug this in. Later, I will tell you a way to calculate the probability you go in a bus station and you get a bus exactly at that moment. Yeah, and this is useful. That's why we learned this. So this is what? This is the probability of k event occur during a time interval. This kind of thing is like what? This kind of thing is once I finish the coin flip or tossing the dice, the end. But this is like what? What's the probability I stand in the bus station for 1 hour, don't move, and then what's the probability within that 1 hour I see 5 buses, something like that. So this is like what? This is like you go to the bus station. Let's say I guess most of you take U1C, right? Then what? Let's say you go to the bus station and let's say on an average day you say, okay, I am not so happy today. At most I wait 10 minutes and then I'm going to calculate. If I stand in the bus station for 10 minutes, after that I explode. Okay, let's say I spend 10 minutes in a bus station and the probability I see one U1C, what's the probability? You plug in here. Then you can calculate what's the probability you see one bus in 10 minutes, and then you can change what? You can change the time, like what's the probability I stand there 20 minutes, see 5 buses, or what's the probability I stand there, what? At most 15 minutes, but I see, given a condition, I see 1 bus. Or then you can see now things can combine together and become very interesting. It's like find the probability, you go to the bus station that, for example, you spend at most 30 minutes and you want to see at least 2 buses. Why at least 2? Because sometimes when you even see a bus, there are so many people, you can't get into the bus. So you want at least 2. Then you will calculate the probability of you see 1 bus or you see 2 buses, and then you have a sum rule and then you calculate everything like this. So that's why this one is very useful. Okay, I'll talk about it in the end. Okay, and this one actually I'm not going to have exam. Just to let you know. Okay, most likely it's binomial. Okay, so let's talk about the simple one. Ballooning. Ballooning is very simple. You just have 0 and 1. That means success or fail. And what's the theta? Probability of success. So theta is some number between 0 and 1. That means if theta is 1, always success. Theta is 0, always fail. Theta is half, is a fair flip. If theta is success, then 1 minus theta means fail. Simple. Okay, so I have this. Since x is only 0 and 1, so actually this is just a redundant way of saying, if I want success, then I have theta. If I have failed, then I have 1 minus theta. That's it. That's it. Okay, so what is a success? Success is I see success given a number, then it's theta. What is fail? 1 minus theta, which means x is 0. Because x only can take 0 and 1. This is a sample space. So I only have these 2 numbers. So this expression looks very fancy, but don't forget x is only 0 and 1. You only have 2 values. So you only see theta or 1 minus theta. That's it. That's it. And we write a very fancy symbol called x. And then this symbol means in terms of probability distribution, x follow this thing. Then we call this, and this is called ballooning. You spell burr. Some people just write a B, or you spell the whole name ballooning. If I have a ballooning random variable, theta is the successful rate. What's the expected value? What's the variance? What is Ex? All the possible x multiply the probability and sum together, right? This 0 means I see small x is 0, which is fail, right? The probability of fail is 1 minus theta. I just told you, right? This means what? I see success. What's the probability of success? Theta. So I have this. Anything times 0 is 0. So 0 plus theta is theta. So that means if you have a coin flip, let's say $0 and $1, and the flip is 50-50, then every time you flip it, on average, you get $0.5. That's the meaning. And this 0.5 is exactly what? The success chance. In other words, if I have a coin, it's unfair. 0.75 chance success and 0.25 chance fail. Then, if you flip it, on average, you will see 0.75, which is not 1 and not 0. One thing, almost forget, this is interesting. What? In probability, we are saying that x will take random value inside a sample space, right? Does it mean expected value is always within the sample space? No. For example, in a coin, either 0 and 1, but expected value is half. So this thing is possible not in the sample space. Okay? Same for the V. And then here's another thing. For ballooning random variable, all the x power become x. That means what? That means if I have ex squared, if you do the formula, you need what? You need x squared times px, right? And then take over all the possible cases. For ballooning random variable, it's so funny that x squared is x. So that means what? This thing is theta, right? It's the same as I put a 21 here. So the expected value of x power 21 is also theta. And I put a 9 here. It's the same. Okay? Because x squared is x. Then x219, okay, x219 is what? Is x217 and then x squared. This is, because of this is x, so I reduce the power by 2, and I can decrease it by 2, decrease it by 2. That's what? Recursion. I decrease it by 2, decrease it by 2, decrease it by 2. In the end, I will have xx, which is x squared, and I decrease it by 2, I get x. So x whatever power is always x. Okay? And then now, this is the same. If I don't know this, and I really do this math, oh, it's the same. Because 1 squared is 1. So I still get theta. Lastly, what about Vx? Vx is what? Let me recap. Vx is a funny E with a funny F, that this F looks like this. Right? But I can also do this, right? It will be the Ex squared minus Ex whole thing squared. And since this guy is just theta, so I have theta. This thing is theta. So I have theta minus theta squared. So I have this. So that means on coin flip, on average, if your coin is fair, then on average you see half. What about the variance? It will be half times half. That means 0.25. That's the variance. Then what about the next one? Well, if you flip many coins at the same time, you get binomial. Let's recap what is this. 4D2. Flip a coin 4 times. 2 means you have 2 outcomes. I'm not going to ask you this D&D terminology in exam, don't worry. Okay? So it means I flip coin with 2 outcomes, 0 or 1, 4 times. This is all the possibility, right? Then if you look at this, what's the chance of seeing this and what the chance of seeing this are all the same. Then I can calculate what? How many success and how many fail. Suppose I have 2 success, 2 fail. Then it's like 2 1 here and 2 0. So it's this case, this case, this case, this case, this case, this case. I have 6 cases, right? What about the other case? Other case will be all fail or all success or 3 fail, 1 success or 3 success, 1 fail. I didn't draw all of them. Okay? Then here are all the 6 possible cases, 2 fail, 2 success. Then what is this? The probability of 2 success happen and 2 fail happen. And I have 6 of them, so I multiply 6. What is this 6? 4 choose 2. 4 event 2 success. So that's it. So it's the same thing as the combinatorics you have seen. So that's why I said, in my part, I have 3 things. The combinatorics, graph, and probability statistic. Graph is alone, is something totally unrelated, but combinatorics, probability are just the same thing. So therefore, I can ask you this kind of thing in the exam. I have 1 to 9, 9 digits. 1, 2, 3, 4, 5, 6, up to 9. I randomly permute this 9 number. What's the probability that you get a number 3 is before 5? Or I have 9 digits, 1 to 9. I randomly choose 5 digits. I form a number. What's the probability this number is divisible by 2? That means what's the probability I find something that is even number? Then it will be what? 9 choose something, right? What about the something? Then that's combinatorics. It's not probability. Okay? That's why I said the combinatorics part is so important. Therefore, I spend so much effort on so many methods on that. And one of the most powerful methods is generative function. This is what? Generative function. Then now we go to binomial. Some people write BI, or some people write BIN, or some people spell the whole word BINO. It's the same. So now what's the sample space? The sample space is you toss it n times, right? Then the outcome is how many success. So suppose you toss 10 times, you want 5 success. Then the 5 is what you want. This 5 belong to no success and all success, right? So no success means 0. All success is actually how many times you flip the coin? 10. So 5 is between 0 and n. So k is between 0 and n. Okay? What about the theta? Theta is again, every time when you flip a coin, there's a chance, right? Then this is the theta. Okay? And then we have one important assumption is that these n flip are all independent. That means if you flip the first time, it won't affect the outcome in the second time. In some situations, this is not correct. For example, in some scientific experiment, it looks like balloony, but maybe once you do some experiment, some machine will crack. And when the machine cracks, it will affect the result next time. Then in that kind of situation, this is false. Then that is not independent. But here, we assume it's independent. Okay? And we also assume what? Identically distributed. That means if you toss the coin 10 times, all these 10 coins are the same balloony coin. It won't toss, let's say it won't happen. Like you toss 5 times, suddenly in the 6th time, this coin become a dice. Then that is not it's not identical. Identical means all the coins are the same thing. Okay? So we assume NIID. IID, do you remember IID? Okay? And then what's K? K is exactly K success. Here is what? 4 choose 2. Toss 4 times, exactly 2 success. Do I have 3 success? No. Do I have 1 success? No. Right? Then you have this. This is what? N choose K is the binomial coefficient. And then what? K times success, right? Theta is the success probability. So you multiply the probability K time. 1 minus theta is a fail, right? So if K times success, then how many times fail? N minus K. Then this is how many probability you fail all those failing case. N choose K is counting how many possible way here you have for the combination. Then you will ask what's the expected value of this. Recall that for balloony, okay, for balloony, the expected value is theta. That means if you have a fair coin, on average, every time you flip it, you get 0.5. Then here is the same question. If I do the same thing, but I flip 10 times, what will be the average result? Okay, here is the answer. It will be how many times you flip times 0.5. Let's say the coin is fair. So imagine, if you flip a coin 10 times and the coin is fair, then you should expect at least half of them is what you want, right? So that's exactly the meaning. This is what? Word, English. What's the math? Math is you have x. X is your random variable. Now I call this x following binomial distribution. What is the x? What I'm talking about x. X is how many times a success. So it will be what? x1 plus x2 plus x3 plus x4 up to xn. Let's say x10. What does this x1 plus x2 plus x3 plus x4 mean? If x1 is success, then x1 is 1. If x2 is fail, then x2 is 0. If x7 is fail, that means x7 is 0. Then I sum this is the same as I record how many times I success. So this means how many times I success among n time. Right? So if I have a fair dice or fair coin, I flip it 10 times, then n is 10. Because the coin is 50% chance, then on average I should see 5 success. So x should be 5, which is 10 times half. How do you get this? I find this. What is this? This big X is this sum of n independent IID balloony variable. So I have this. And since expectation is linear, do you remember there's a big slide with so many equations? I can put the E inside the summation sign. So I have this. And each of these xi is what? Is IID balloony. And balloony is what? The EX is theta. So I have what? This thing become theta. How many of them? N of them. So n theta. That's it. So if I toss 12 times and the coin are fair, on average I should see 6 success. This is how you get the EX on binomial. Trivial, right? What about variance? So suppose I want to find this. Now I have what? Let's say I toss 10 times. I want to find EX squared. Okay, then let's do this. So EX squared is what? X is this big thing. So I have this big thing. This big thing, whole thing square. So I have this. What the heck is this? Here is the example. Suppose I have 4, so x1, x2, x3, x4. I squared it. I draw a table. You should now very comfortable with this table. It's the same as toss 2 dice, and then I write down all the 36 combinations. So I get this, and then I combine their power. And then if you look at this diagonal is a x1, x2 square, x3 square, x4 square. So they have one index, x something square. What about the off diagonal? The off diagonal are mirror image. 1, 2, and 2, 1 are the same. 1, 3, and 3, 1 are the same. So I have this thing times 2. So I have this thing. This means what? I have all the individual term, just x1 something square times plus this. Then now I have this. Okay? And expectation is linear. I can put an E inside. So now I have these 2 expressions. What is this thing? Because each of the coin is balloony. So remember, x squared is x1. X whatever power of a balloony is just x. So I can ignore the power. I have this. Then what about this thing? This thing no change. I keep it here. But because they are independent random variable, I can split them. So this part, because of the rule, I can split them. So now I get what? I get this EX squared equal to this thing. Now what is this? This is a bunch of Bernoulli trial. E of Bernoulli is theta. So here, this thing becomes theta. So this part becomes n theta. Okay? What about this? These are also Bernoulli trial. So they are all theta. So I have theta theta, which is theta squared. So now I have this thing. Right? And how many theta squared here is the same as how many things are here? Because this is 4, this is 3, so 4 times 3, or in general, n times n minus 1 divided by 2. So I have this funny thing. I simplify the math. The variance is n theta times 1 minus n. What is this? This thing is exactly the variance of a Bernoulli trial. This is the binomial n. So in other words, for binomial distribution, the expected value is just the Bernoulli times the number of times you try it, and the variance is the same. You just have the same variance of the Bernoulli, multiply the n. And that's the binomial random variable. Then here's the example. What's Bernoulli? You either win or lose. And now suppose you gamble 5 times. What's the probability at most to win? Then what is this? Win nothing. 5 times or lose. 5 choose 0. Win 1 time. Lose 4 times. Win 2 times. Lose 3 times. Multiply the 5 choose 1 and 5 choose 2. Then you get this number. And you plug it in those theta, you get the probability gamble 5 times, win at most 2 times, and this gives you a number. Here's another thing. Suppose if you win, you get $40, and if you lose, you minus $10. The outcome is 0.5. Find the expected return of at most 2 win in 5 gambling bet. So that means what? That means now you gamble 5 times. You want the following. The rule is you gamble 5 times. You cannot quit in the 4th time. You have to gamble 5 times. Number 1. Number 2, each time you win, you get 40. Each time you lose, you minus 10. And then the win rate is 0.5. And now you want to know if at most you get 2 win, what's the expected return? This means what? You are not so brave. You think that, oh, I can't win all the 5 times. Oh, I can't win 3 times. 3 times is too ambitious. Let's say I only want to know, on average, how much I will get if I only win 2 times. Then you calculate this thing. What is this thing? All time lose. And since you lose how many times? 5 times. So this means what? Lose 5 times. So 5 times this lose. Okay. What is this? You win 1 time, lose 4 times. So win 1 time is 40. Lose 4 times, so minus 40. So this actually should be 0. Okay, I made a mistake. And then what is this? Win 2, lose 3. And then you calculate 2 times this, minus 3 times this, you get a number. And then you multiply the corresponding probability. What is this? This is actually EX. EX is the event X, multiply the probability of X. This is probability, this is probability, this is probability. This is the X, this is the X, this is the X. So I'm actually just doing EX. And now you can calculate all this thing. And if you are very comfortable with all these things, you can become a professional gambler, which I don't want you to do. Now you see this is how you calculate gambling. What's the strategy? The strategy is, if you are not so brave, you are saying that, let's say you gamble 5 times, and you are saying that, let me be more conservative. I don't think I will win all the time, so I think I win at most 2. And now if this expected return is higher than my input, then I should go. That's the idea. And here's another example. Trinomial. If you do binomial, then you naturally know trinomial. I talk about it many times. So I will skip this. So here's another gambling. So suppose you now have 4 choices. You have big win, win, lose, and super big lose. Okay? And you also have the probability. Big win is 0.1, 10%. Win is 40%. Lose is 45%. Super big lose, very unlikely, 5%. You do the same thing. You want to find the expected return. At most 2 win, but this time it's more complicated. Win means either win or super win, okay? And you bet 5 times. Then how do? You do this thing. So now you have 4 events. This is a quadrinomial gambling. So you have 4 things. The PPPP stands for X, Y, Z, W, means how many times you big win, how many times you win, how many times you lose, and how many times you super big lose. And then what? 5 choose X, Y, Z, W. Multiply each of the probability. This will be a P, right? Then what about the expected value? This P multiply the outcome of the win-lose, you will have an X. You sum over all this thing, then it give you the expected return of if you have this gambling, should you go or not go?